Good morning. Myself Priyesh Jha, and I am chemistry faculty of TAKSH-SHILA Model Senior Secondary Public School, Faridabad. Today I am going to start a lecture for class 12th of chapter Electrochemistry. In the previous class we have discussed the molar conductivity, variation of molar conductivity with dilutions, Kirchhoff's law and their applications. In this class, we will start a new topic, that is electrolytic cells and Faraday law of electrolysis. The first topic of today is electrolytic cell. Lytic cell. Generally, what is electrolytic cell? So electrolytic cells are those in which oxidation and reduction reaction takes place in the same container, or the cell which is used for electrolysis, generally known as electrolytic cells. इलेक्ट्रोलाइटिक सेल में क्या होता है, दो इलेक्ट्रोड दैट इज कैथोड एंड एनोड इमर्ज्ड इन द सेम कंटेनर, द वन in which oxidation takes place known as anode and the other at which reduction takes place known as cathode, and these two electrodes are joined by external circuit through a battery. So the general construction of electrolytic cell is like this. Suppose this is electrolytic tank in which two electrodes are immersed, that is one is anode and another is cathode. Suppose these are two electrodes and these electrodes are joined by external circuit So this electrode generally known as anode having positive charge, and this electrodes generally known as cathode having negative charge, and this is the electrolytic tank in which some electrolytes are present. At anode generally oxidation takes place, and at cathode generally reduction takes place. So at anode oxidation takes place, so it will release electrons, and cathode generally reduction takes place. So at this electrode generally this electrodes generally takes electrons and becomes reduced. Suppose some electrodes are present, like for example NaCl. When this NaCl dissolve in this solvent, this will break down into Na positive and Cl negative. So we know in opposite charge generally attraction takes place. So this negative charge will move towards anode and this positive charge generally move towards कैथोड. हमें पता है कि अपोजिट चार्ज में क्या होता है, अट्रैक्शन होता है, एंड सेम चार्ज में क्या होता है, रिपल्सन होता है. जब ये पॉजिटिव और नेगेटिव कैटायंस और एनायंस में ब्रेक होगा तो जो पॉजिटिव होगा जनरली किसकी तरफ जाएगा, कैथोड की तरफ, और जो नेगेटिव होगा जनरली किसकी तरफ जाएगा, एनोड. अब होगा क्या कि ये Na पॉजिटिव या कोई भी सब्सटेंस जो एक्सटर्नल सर्किट से इलेक्ट्रॉन्स आ रहे हैं उसे एक्सेप्ट करके क्या जाएगा, रिड्यूस हो जाएगा, और ये जनरली क्या जाएगा, ऑक्सीडाइज हो जाएगा. सो इन दिस फॉर एग्जांपल ऑक्सीडेशन half रिएक्शन जनरली किस पे होगा, कैथोड पे, at anode. This Cl negative converted into Cl2 plus 2 electrons and reduction half reaction at cathodes. So this Na positive takes electrons and converted into Na, and when we write overall reaction, then this will be Na positive plus half Cl2 negative gives NaCl. तो एक जनरल रिएक्शन होता है. अब क्या होता है, इन दिस process generally some amount of any cations deposited at cathode, and in the same way same amount of any substance liberated at generally anode. So there are, and this amount generally depends on electricity, how much electricity pass through the electrolytic cell. So इसके लिए generally we know the rule generally known as Faraday law, and Faraday law generally express how much amount of substance will liberated at anode and how much substance will deposited at cathodes. So there are generally two law. So the first law is Faraday first law. So according to Faraday first law, the amount of substance deposited at any electrode is directly proportional to the charge flow through the circuit. In mathematical way, W directly proportional to Q, mass of substance deposited or liberated at any electrode directly proportional to charge flowing through the circuit. And when we remove proportionality constant, it is written as ZQ or W is equal to ZIT, because Q is equal to generally I into T, where Z is known as electrochemical equivalent, generally electrochemical equivalent, and this Z can also be expressed in the expression like atomic mass into I into T upon n factor into 96500. तो ये एक फाइनल एक्सप्रेशन हुआ फॉर न्यूमेरिकल के लिए, और यहाँ पे जो Z की वैल्यू हो गई वो क्या होगी, A मतलब एटॉमिक मास अपॉन n फैक्टर इंटू 96500, ये Z के इक्वल होता है. ओके, सो एंड दिस इज नोन एज Faraday 1 Faraday is the value of 1 Faraday 9650, and Z can be defined as generally W is equal to Z I into T if I equal to T equal to unity. Suppose 1 ampere of current flowing through 1 second, then W is equal to Z. So Z is equal to amount of substance deposited or liberated when 1 ampere of current is flowing through 1 second. ये होता है. अब मैथमेटिकल हम न्यूमेरिकल कैसे सॉल्व करेंगे, इसके लिए क्या होगा, चार्ज रिक्वायर, चार्ज required for deposit 1 mole of any substance is equal to n फैराडे की इक्वल होता है. The amount deposit for 1 mole of substance, the charge required in n Faraday, where 1 Faraday is equal to 96500 coulomb per mole. For example, charge required for the following: 1 mole of Cu2 positive to Cu. So this Cu2 positive generally converted into Cu. Here the charge is 2 and here the charge is 0. So the difference is 2. So we add 2 electrons in reactant sides. So here n is equal to kitna? 2. So the charge required is equal to 2 Faraday. Okay. Another example. One mole of Al3 positive to Al. Al3 positive generally converted into Al. So the difference in charge here 3 positive and 0. So 3 electrons. So n is equal to 3. So Q is equal to 3 Faraday. तो इस केस में कितना होगा? 3 Faraday. Next example. 1 mole of Mn4 negative to Mn2 positive. Here in the case of MnO4 positive, the oxidation state of Mn is +7 and the oxidation state of Mn is +2. So the difference of charge is 5. So n is equal to 5. So Q is equal to 5 Faraday. तो ऐसे हम क्या करेंगे? न्यूमेरिकल सॉल्व करेंगे. And this is according to Faraday first law. And we will learn Faraday second law. Faraday second law. Faraday's second law generally used when two or more electrolytic cells are connected in series, because in series current are same. Suppose two electrolytic cell I, this is A, B and C. In this case the charge for each electrolytic cell is same. So according to Faraday's second law, the amount of substance deposited or liberated at any electrodes when two or more cells are connected in series directly proportional to their equivalent weight. So when we write for two electrolytic cells, suppose amount of substance deposit A upon में amount of substance deposit B is equal to equivalent weight of A upon equivalent weight of B. तो ये जनरल एक्सप्रेशन होता है. और इक्विवेलेंट वेट कैसे निकालते हैं? इक्विवेलेंट वेट इज इक्वल टू एटॉमिक मास अपॉन चार्ज या एसिडिटी या बेसिसिटी. इन केस ऑफ चार्ज जनरली टेक्स प्लेस इन द केस ऑफ सॉल्ट एंड H पॉजिटिव एंड OH नेगेटिव इन द केस ऑफ आयंस. फॉर एग्जांपल Cu2 positive, equivalent weight of copper is equal to atomic mass of copper is equal to generally 63.5 and this contain 2 charge, so 2. तो equivalent weight of copper 2 positive कितना जाएगा? 63.5 upon 2. For example Al3 positive, equivalent weight of Al is equal to atomic mass of Al is equal to 27 and this contain 3 charge. तो ऐसे निकालेंगे हम equivalent weight. तो ये जनरली होता है फर्स्ट एंड second law. First law generally says that the amount of substance deposited or liberated at any electrode directly proportional to the charge flowing through the circuit. And second law generally says that when two and more cells are connected in series, the mass of substance deposited or liberated at any electrode is directly proportional to their equivalent weight. And how much equivalent weight calculated? Equivalent weight is generally atomic mass upon charge. In case of copper having 2 positive charge, the equivalent weight will be 63.5 divided by 2. And in case of Al3 positive, equivalent weight generally 27, because 27 is atomic mass and this contain charge 3. So 27/3. तो ये ऐसे हम क्या करेंगे, सॉल्व करेंगे. तो ये क्या हमारा था, टॉपिक था फॉर टुडे. एंड नेक्स्ट टाइम we will discuss a next topic. And for today, thank you.